Okay. Good afternoon to everyone, and welcome to this academic environment. My name is Camilo Acevedo Gerena, and I'll be guiding you throughout this PhD candidate dissertation. On behalf of the Doctoral Program in Engineering at the Universidad Pedagógica y Tecnológica de Colombia, Sogamoso, we welcome you to this dissertation of the PhD proposal entitled A PBL Approach for Fostering Creativity in Engineering Students, presented by student Oscar Iván Higuera Martínez under the supervision of Professor Liliana Fernandez Samacá. This dissertation has been scheduled by the academic board of the Doctoral Program in Engineering. It is led by Professor Germán Antonio Fernandez as academic coordinator of this program, as well as Professor Wilson Javier Perez and Jorge Espíndola Niño, who represent the research groups involved in this PhD program. We also welcome Professors Giovanni Corazza, Jose Peña, and David Copley as reviewers of Oscar proposals, as well as the rest of the professors and PhD students of our doctoral program that are with us via Meet. We suggest you to turn on the captions that are available on the Meet's toolbar. And of course, we thank all the people that follow this stream via YouTube. Good afternoon, Oscar and Professor Liliana. Welcome to this event. Then we're going to introduce Oscar, his advisor, and the evaluation committee. Oscar Iván Higuera Martínez. Engineer Higuera holds a bachelor's degree in electronics engineering from Universidad Pedagógica y Tecnológica de Colombia and a master's in industrial automation from Universidad Nacional de Colombia. He's an assistant professor at UPTC and works with the Electronics Engineering School. His research interests include signal processing and engineering education. Liliana Fernandez Samacá, Oscar's advisor. Engineer Liliana holds a bachelor's in electronic engineering from Universidad Pedagógica y Tecnológica de Colombia and a master's degree in industrial automation from Universidad Nacional de Colombia. She is a doctor in electrical and electronics engineering from Universidad del Valle, Colombia. She is an associate professor at UPTC and works with the Electronics Engineering School. She is the former coordinator of Electronics Engineering Doctoral Program at UPTC. Her current research interests include control system education, project-based learning, and engineering education. Giovanni Corazza, University of Bologna, Italy. Giovanni Emanuele Corazza is a full professor at Alma Mater Studiorum, University of Bologna, president of the Fondazione Guglielmo Marconi, founder of the Marconi Institute for Creativity, member of the Marconi Society Board of Directors. He was member of the Board of Directors at the Universidad of Bologna from 2012 till 2018, president of the Consortium for Computing from 2017 till 2019, member of the Partnership Board of 5G Infrastructure Association, head of the Departments of Electronic, Computer Science and System from 2009 till 2012. Member of the Board of 5G Infrastructure Association and Vice Chairman of the Network 2020 European Technology Platform from 2013 till 2016. José Ismael Peña, Universidad Nacional, Colombia. José Ismael Peña Reyes is a full professor at the Universidad Nacional de Colombia. He holds a bachelor's degree in system engineering at the same university in 1989. He also holds a master's degree in information system management and technology from the University of Geneva in 2004, now known as the Grenoble Alps in 2005. He's a doctor in management science from the same institution. He's currently the National Director of Extension, Innovation, and Intellectual Property from Universidad Nacional de Colombia. David Cropley, University of South Australia. David Cropley is an international recognized expert on creativity and innovation. He's a professor of Engineering Innovation School at the University of South Australia. He's chartered physicist and member of the Institute of Physics, London, member of the United Kingdom Naval Review, professional affiliate Division 10, Aesthetic, Creativity and Arts, American Psychological Association. His teaching interests focus on system engineering and related concepts. His current research examines a range of aspects of creativity and innovation, both in the field of engineering. And last but not least, the head of the doctoral program, Professor Herman Fernandez, the doctoral coordinator. Herman Fernandez holds a bachelor's degree in electronic engineering from Universidad Autónoma de Colombia. He holds a master's degree in electrical engineering from the Universidad de los Andes, Colombia, and industrial automation from Universidad Nacional de Colombia. He is also a master's in system and communication networks from Universidad Politécnica de Valencia, Spain. He is a doctor in telecommunications at the Universidad Politécnica de Valencia. His research interest includes wireless communications propagation modeling. His current research is focused on channel measurement and modeling in vehicular communication. Now, I'm going to go over the methodology for this current session. The methodology for this dissertation consists of 3 stages. First, Oscar will have 30 minutes to present his proposal. Second, the reviewers participating in this dissertation can ask Oscar questions in order to confirm that he addresses their suggestions and observations. Later, attendees with a PhD can also take part in this stage. Finally, at the end of the question time, Professor Liliana Fernandez, as advisor of Oscar, will have time for brief feedback. Only the first stage will be streamed via YouTube. We thank all the people that are connected and following us via YouTube. Now, we invite Oscar to start his presentation. Welcome, Oscar.
Thank you. Good morning, good afternoon. Welcome to my doctoral candidate examination. I'm Oscar Higuera, and today I'm going to talk about my PhD research proposal entitled PBL Approach for Fostering Creativity in Engineering Students, under the direction of Professor Liliana Fernandez. Thank you for attending this online presentation. Colombia has 36 public universities. One of these is the Universidad, Pedagógica y Tecnológica de Colombia. This university has 63 undergraduates, 40 masters, and 11 doctoral programs distributed in 4 campuses. In our campus, Sogamoso, we have 8 undergraduate and 50 postgraduate programs, including the doctoral programs in engineering, which is associated with the Electronic Engineering School. We work with the Signal Processing Research Group that has 4 research lines: signal and image processing, instrumentation and industrial automation, agricultural and environment technology, and engineering education, in which I carry out this PhD proposal. Please, let me introduce the agenda for today. Firstly, I'm going to present a motivation and problem statements and theoretical background. Then I will talk about the state-of-the-art, research question and objectives, methodological research design, and finally, I present show preliminary results. Motivation and problem statement. We can observe the importance of engineering in the human history through the design and build of tools and devices and to facilitate the work, and as the awareness of comfort. Now, we observe new challenge appears. Just look around the global goals and grand engineering challenge. and we can realize about the crucial role in engineering to solve problems regarding this challenge. The National Academy of Engineering of the United States say the solution of this challenge will have large engineering component, although engineering cannot solve the challenge alone. Neither can the challenge be solved with engineers. Moreover, Revolution 4 and 5 generate new challenge and demand new capabilities. This new challenge demand flexible and dynamic technology. And in turn, it demands ICT engineering with the continuous growth of the technology and transversal skills, especially in this current digitalization era, where engineering design and tools aim to versatility products. Considering the role of higher education on engineering to encourage students to lead creative solutions and to create sustained novel solutions for contextual challenge, we observe the importance of the curriculum design, where the problem solving appears an important education issue and creativity result remarkable. We have the challenge to foster creativity, and the challenge is still in for discussion topic in engineering. Engineering is properly considered a design profession. Design is the heart of engineering. In other words, to recognize creativity as a fundamental skill that precedes innovation. Thus, we can observe a direct relationship within strength of training on creativity and technology development, and therefore a strong relationship between engineering education and fostering creativity and innovation. Then, this means to understand problem solving as a crucial skill to promote social and economic development, and creativity as an opportunity to simulate idea generation and subsequently implement novel producers, practices, or products. We must pay attention to the educational environment generated by teacher attitudes. Then, this includes acceptance of ambiguity and risk-taking, viewing failure as opportunity to learn, and the habit of searching for multiple answers beyond a correct one. Thus, we observe there are barriers to creativity in ICT programs, like a lack of poor conceptualization of creativity by students, little attention to creative by teachers, lack of systematic effort for building of creative learning culture in institutions. Some studies debate about the inadequate problem-solving performance of engineering graduates, which commonly relies on an insufficient time for activities aimed to develop problem-solving on skills. For example, Professor David Cropley sums up the need to foster creativity in engineering, referring mainly to this connection between creativity research and the practice of engineering design, and the need to use cross-fertilization, and mention that without this cross-fertilization, engineering design will remain anchored in convergence and analysis. We will talk about creativity and innovation in our context. In the Global Innovation Index of 2020, that presents the global innovation trends and innovation performance of 131 economies, Colombia is in position 68, below the world average, and in the place 80 in the pillar of creative output that include industrial design, ICTs and organization model creation, mobile app creation, among others. Colombia developed the Department Innovation Index, the same sense of the global index. In this, Boyacá, our region, is in position 11 of 31 departments. And regards of pillar of creative output, Boyacá is in the group of medium-low performance. This report indicates that also Boyacá is overcoming the gap between input and innovation results, has a medium-low performance that relies on the lack of dynamism that is shown in both knowledge and technological production and creative productions. In conclusion, the results show the need to improve innovation and creativity in our country and in the region. Creativity and innovation are crucial in engineering for social and economic development. Why is it not an obvious part of every university's engineering curriculum? To understand the need to include creativity in curriculum, some question us to help to rethink the importance of creativity in engineering, its importance, its needs, and its contribution. Why should engineering organizations, their leaderships, their professionals, as well as the educational institutions be concerned with creativity in engineering? What do engineers do that require creativity? What do we need creativity and innovation in engineering? In summary, what is creativity in engineering education largely overlooked? This reflection motivates us to know what happens with creativity in engineering education and raise the importance of including fostering creativity in engineering curriculum. Then, from the previous analysis, we can consider three aspects. ICT programs are fundamental for developing new products and innovation, especially in the digitalization era. In engineering, creativity results a critical issue in the development of suitable and affordable technology for facing challenges of the context in generating new solutions to the problem that exists. And finally, engineering has a crucial role in economic and social development. And from an educational point of view, in curriculum design, we must consider involving creativity as an essential part of engineering education to realize its full potential. That educational approach for fostering creativity in engineering must encourage the development of skills to solve problems and execute projects. There is an evident need to create or develop new approaches to strengthen creativity in engineering that deal with engineering design. Theoretical background. There are many models and theories on creativity. We can observe that the work on creativity starts from 4 authors and 5 remarkable works, which are the main conceptual framework. Historically, different definitions of creativity have been given from anthropological, psychological, or philosophical view. For this proposal, we choose the Plucker definition. We observe the most of the creativity definition considering 5 elements: product, process, social context, environment, or quality or condition of being creativity. Plucker definition consider these 5 aspects. Most known creative models are the 4P model that consider person, process, product, or press or environment, which later was extended to 5P phases that result suitable for engineering. Other models are the componential model of creativity, system model of creativity, and the investment theory of creativity. About how much creativity is a person appears the level of creativity, considered 6 levels. For example, the little C that relies on the daily problem solving and creative expression. For example, a child who paints a landscape in the school. To big C and boldface C, which is reserved for individuals who create something great. For example, Leonardo da Vinci, Rembrandt, Van Gogh, or Monet. We can note that models and theory share elements like motivation, domain knowledge, and expertise, divergent and convergent thinking, and the set of personal characteristics such as openness to experience, tolerance to ambiguity, willingness to take risks, and supportive environment. In short, we can see that the creative process as a road to obtain the creative results. In creative process, we must consider different factors like originality, to evaluate if an idea is unique, fluidity, to have a lot of options, flexibility, to observe if option aims to diverse possibilities, elaboration, quality of ideas, divergent thinking, the capability to generate ideas, convergent thinking, the capability to select a good idea, motivation, among others. Worth noting that the creative process phases are developed in stages. The researchers commonly use 4 to 8 stages that we can group in 4 big ones, namely analysis, generation, evaluation, implementation, or communication. In the slide, you can observe 2 examples of model of creative process. One proposed by Professor David Cropley, who proposed 7 stages, and that no design thinking model, the proposed by Brown of IDEO. Engineering is concerned with solving problems, and we can note that the solution does not emerge in a single step. Engineering uses a sequence of stages, therefore solving a problem follows a design process, and consequently require creativity. Then we can observe a close relationship between the need for fostering creativity and development of problem-solving skills. Now, we are going to discuss creative thinking in the creative process. One of the essential factors in creative is a person. Creative thinking appears an ability, a subcomponent of creativity that concerns the ability to generate ideas and solutions that are novel. This is an indicator of the creative potential of the person. The creative process involves both divergent and convergent thinking, where divergent thinking relies to generate multiple ideas as possible solutions to a specific problem. In contrast, convergent thinking means the ability to give a correct answer, to understand questions or solve problems, or choose the right option. In areas, we should combine divergent and convergent thinking for obtain novel solutions. You can observe that in each stage, the creative process, divergent and convergent thinking, results are crucial. Figures show a synthesis of the innovation and highlight of relevant information in the theoretical background. In summary, we take a central issue of creative process, from the creative definitions, its factors, its models, its phases, including the creative assessment that considers 2 points of view, one regards the individual and another of the product. The main tests used to assess the person are the tolerance test of creative thinking, creative engineering design assessment, and Riesman diagnostics creative assessment. Now, we are focusing on some aspects found in the literature about practices and scenarios for encourage creativity in engineering. We found the PBL approach is an essential way of fostering creativity because a PBL is an student-centered education approach that uses problem or project as a learning scenario. PBL based on 3 main principles: cognitive learning, collaborative learning, and content. The cognitive learning means that learning is organized around the problem and will be carried out in project. The problem provides the starting point for the learning processes, places learning in context, and bases learning on the learned experience. The content supports the relation between theory and practice and promotes exemplarity in learning activities. And the social or collaborative approach is team-based learning. The team-based learning aspect underpins the learning process as a social act, where learning takes place through dialogue and communication. These 3 principles guarantee the PBL effectiveness in engineering education. In our case, we consider relevant Model 2, now with a PBL for professional action, where knowledge is concerned to the performance oriented in a problem scenario characterized by a real-life situation. Then, PBL promotes aligned curricula, which involve different elements such as objective and knowledge, type of problems, projects or lecturers, progression size and duration, students learning, academic staff and facilitation, space and organization, assessment and evaluation. In project-based learning, the problem is the starting point, and the project is the route to get a solution to the problem. We observe that this approach is strongly connected to the development of problem-solving skills, and of course, to the creative process. Regarding the relationship between PBL and creativity, characterized like problem orientation and work, group learning context. The process of collaboration is searching for solutions. The shift from teaching to facilitation. The idea is facilitating the student direct learning rather than teaching, demonstrate the strength of the PBL for developing creativity. State of the art. For establishing the state of the art, we carry out a systematic review following methodology proposed by Tranfield. This methodology defines 4 phases. The first phase comprises to identify database to research articles. In this case, we use Web of Science and Scopus, limiting the searching interval from 2002 to 2020, and seeking to identify the most relevant publications that related for creativity, engineering, or science. The second phase devoted to describe and classify the select document. For this, we define inclusion or exclusion criteria by analyzing the article's component like title, headings, abstract, to keywords. In some cases, we also include the introduction and conclusion. Finally, 405 manuscripts were analyzed, from which some were used as seminal document for theoretical background on creativity, and others to establish state of the art. In the third phase, we detailed the content, analyzing the select reference, and finally, in the last phase, we classify and report the findings, which are going to show the next slide. In this slide, in chart, we compare the contribution closer to the purpose of this proposal. For that, we use 4 main components aspects. The first aspect related to the integration of creatively relevant factors. Another comparing aspect was protocols for creativity assessment, which result crucial to know the intervention results. And finally, the 4 comparing aspects allow us to observe where the creativity is fostering. For example, if this fostering a course, activity, or workshop. If the paper presents the curriculum design for incorporating the activities, and the kind of model used to foster creativity. The result of this analysis show the frequently authors define different phases for the creative process, apply creative tools on learning activities, and commonly contribution online creativity components for diversity thinking. And only some ones integrate creativity learning outcomes as engineering learning outcomes. Moreover, in the evaluation of this common the application of pre-tests and post-tests to assess the creativity of students and the learning trigger, we know the predominant use of problem of projects. Conclusion, we observe a low curricular integration in engineering curriculum design. This means the most of the contribution are pilot experience, particular activities for a specific course, extracurricular activities or activities that are not a structural part of engineering curriculum. Likewise, most of the contribution focuses mainly in one of the kind of creativity thinking, usually divergent thinking. For this reason, one of the main purposes of this proposal is to promote creativity by considering a curriculum design based on an aligned project approach for encourage creative thinking, and thus to encourage both divergent and convergent thinking. Now we are going to classify the contributions taking into account the way to is used to fostering creativity from a learning and teaching practice view. We group the contributions solving the question, how do teach practice and learning practices incorporate creativity in engineering or science programs? Classify to obtain information in 6 groups, which are not excluding. Group 1 corresponds to contributions that define complementary activities. Group 2 has contributions that use laboratory activities. Group 3 shows those to apply novel methods on mathematics or science. Group 4 comprise contributions that incorporate disruptive activities, for example, activities with art, theater, or cooking. Group 5 has contributions that design course in creativity or a specific training program. Group 6 corresponds to contributions that use problem and project. In this case, we found that the work apply approach as TRIZ or PBL. We found the PBL as an effective way to promote creative thinking because align the project, teaching and learning activities, assessment, facilitation, and pedagogy. Finally, this chart shows the main aspects of contribution that we have labeled as remarkable papers that use of problem or project. Their classification considering 4 main aspects. The first aspect is focus. The activity is exclusive for creativity or integrate other skills. The second aspect devotes to know of kind of project or problem use and observing the use of problem-based learning. The third aspect labeled scope, evaluate the contribution show and specific training, creativity activities on academic activities, and curriculum design where creativity is integrated. And the fourth aspect regards the assessment. We observe that it is necessary to define models that link projects, technology, technological knowledge, methodologies of the creative process, and creativity assessment by learning scenarios that guarantee the solution of contextual problems with a global view. For that reason, this PhD proposal has a focus to fostering creativity as along other skills, as collaborative work and communication, by using an aligned PBL to use contextual problems as an integrated part of a curriculum design. Research question and objective. We formulate 4 research questions for this doctoral proposal. The first, how to foster creative thinking in an engineering program from a student-centered education approach that involve problem or project as learning trigger. Second, what to integrate fostering creativity as an integral part of an engineering curriculum. Third, how to contextual problems trigger creative thinking in engineering students. Finally, are engineering students more effective at the idea generation of the creative process than when they work collaboratively? As a general objective of this proposal is to design a PBL approach that involves creative tools for fostering creative thinking in students of ICT engineering programs by using the contextual challenge as a learning scenario. And a specific objective, this doctoral proposal aims to establish the state-of-the-art training processes on creativity and engineering for identify significant experience, define the curricular structure for disciplinary course following the PBL alignment, emphasizing the application of creative tools. Third, apply the approach designing of a course on an engineering program by analyzing the effect of this implementation and evaluation, the results in developing creative factors. And finally, the design of protocol for evaluating the proposed PBL approach impact on the student fostering of creativity. Objective 2 related to the design curriculum and objective 4 related to the protocol for evaluation are strongly connected. Methodological research design. To develop this This project, we are going to use the methodology of design-based research, which consists of 7 steps in research. Step 1 and Step 2 related to the Objective 1. Step 3 and Step 4 are oriented to the Objective 2, related to the curriculum structure, for example, online the PBL approach, assessment, and pedagogy. Step 5 is to construct the prototype or the solution. For instance, develop the learning materials and projects related to Objective 2 and 3, the intervention design. Step 6, to test and evaluate the solution. In this case, it is associated with Objective 3 and 4. This is to apply the intervention and to design a protocol for evaluation. And Step 7 is to redesign and consider all actions to adjust the intervention to improve the curriculum design, which is an advantage of DBR. We can know the design-based research, this exemplarity way, serves as a creative process scenario for the development of this doctoral proposal. To meet this project, we focus on 2 essential stages, strongly connected with the curriculum alignment and the application of intervention. Regarding the curriculum structure design, this will be define all course characteristics like learning and teaching activities, support resource, creativity tools, learning environment, facilitation strategies, student assessment, among others. Regarding the evaluation protocol, we'll consider creative tests, participant observation and intervening groups, and interviews with participant questionnaires and specific on variables in issue of curriculum design, which will allow us to have quantitative and qualitative data collection. We are going to apply with now creative tests, considering pre-test and post-test. These tests we will apply to both the intervened group and the control group. The control group will consider students who have similar course but no participant in the PBL intervention. The design protocol for evaluation is the more important stage for data validation in this research. For determining this impact of the PBL intervention, we will compare the intervening and control group students' performance for establishing the correlation among variables considered in the evaluation impact. Proposal timeline considering 4 years. Currently, I am in the end of my 2nd year, and it is shown in the schedule. At this time, we are defining the curriculum structure along with the general evaluation protocol. You can observe in this schedule that the design of the curricular and the protocol of evaluation is in parallel. The intervention will be carried out in the first term on 2021, which will start in May because due to the pandemic, currently the semester at UPTC has a delay. And I hope to start my international academic stay in the 2nd term of 2021, but it's possible that it start in the 1st term of 2022. Preliminary results. Finally, the obtained results have been documented in 1 journal paper and 2 conference papers. We submit a journal paper entitled Trends and Opportunity by Fostering Creativity in Science and Engineering, submitted in the International Journal Education Research Review. Likewise, we have presented some results in a specialized conference as the International Research Symposium on PBL. The paper entitled Fostering Creativity in Engineering Through PBL. Main focus was to show the relation between creativity and PBL work. And in Colombia, we present a conference paper entitled Promotion of Creativity in First Years Engineering Students Through Projects in the International Meeting of Engineering Education organized by the Colombian Association of Engineering Programs. This paper focused on describing the result of the short PBL intervention for freshman students. Thank you, Professor Liliana Fernandez, for your advice and guidance in this proposal. Thank you, Professor David Cropley, Giovanni Corazza, and Ismael Peña for your suggestion and recommendation on my doctoral proposal. I thank you for all the comments and suggestions that could you give me for the project development. Thank you for your attention. Now it's time for question, recommendation, and suggestion. Thank you.
Thank you very much, Oscar. Now we want to say that on behalf of the doctoral program in Engineering and Electronics Engineering Graduate School, we thank everyone who followed this presentation via YouTube. We are very committed to our academic process and our research oriented towards solving contextual problems. Our doctoral program promotes three fundamental pillars: research as a route to find solutions to local problems with a global view, self-management that encourages the autonomy and self-confidence of our students, and networking that promotes collaboration with international community. We hope that you have enjoyed this event and that its content has been meaningful to you. Thank you very much. Now, like YouTube streaming was over, we are just taking part like on these Google Meets that is like that we have now 21 people over here. So we're just gonna continue with the second part of this process. But before that, I would like to know like